Hello everyone, I'm Enjahni from CSMA section and today my topic is about eccentric semiconductors and from the subject engineering physics and my subject code is 23PHY01 and my bearing roll number is 234Z183357 and this is my topic eccentric semiconductors. Before going to the introduction of eccentric semiconductors, I have to say about semiconductors are classified into two types and they are intrinsic semiconductors and eccentric semiconductors. Eccentric semiconductor also classified into two types, n-type and p-type. And now we are going to introduction of eccentric semiconductors. Eccentric semiconductors are materials that have been initially doped with impurities to modify their electrical properties. Doping introduces additional charge carriers into the semiconductor crystal structure. The two main type of eccentric semiconductors are n-type and p-type. I already told about that. N-type eccentric semiconductors. In n-type eccentric semiconductors, the material is doped with elements that have extra electrons such as phosphorus or arsen. These extra electrons become the majority charges carriers in the material. N-type semiconductor conducts electricity by movement of electrons. And p-type eccentric semiconductors. P-type eccentric semiconductors are doped with elements that have fewer electrons in their outer shell such as boron or gallium. These holes created by the missing electrons act as the majority charges carriers in the material. P-type semiconductors conduct electricity through the element of these holes, and this is the example and picture of the eccentric semiconductors in p-type. Formation of p-n junction. In eccentric semiconductors, we have p-n junction also. By combining n-type and p-type semiconductors, a p-n junction is formed. At the junction, electrons from the n-type region migrate to fill the holes in the p-type region, creating a depletion zone. This depletion zone acts as barrier to flow the current until a bias voltage is applied. And this is the picture of that. Forward bias of p-n junction. When a forward bias voltage is applied to a p-n junction, it reduces the barrier potential. This allows electrons and holes to flow across the junction, enabling current to pass through the devices. Forward bias is essential for the operation of diodes and other semiconductor devices. And this is the picture of that. Have a look of it. Note the barrier's potential cannot be measured with a voltmeter due to the presence of contact potential. The contact potential can cancels VB with the external conductor is attached. And this is the barrier potential and this is the reference potential. And have a look of it, have a look of the forward biasing of PN junction. Reverse biasing of p-n junction. In reverse bias, the applied voltage increases the barrier's potential at the junction. This prevents the flow of current through the device. Reverse biasing is crucial for applications such as rectifiers and voltage regulators. And have a look of the reverse biasing of p-n junction. Positive of bias applied to the n side is reverse bias. A current flow in external circuit from P to N. E exit the N side to the external circuit and H exits the P side to the external circuit. And have a look here. More bound charges are uncovered in both sides. Width of the depletion region means it's also called as DR increases. Voltage across DR increases by VR, the applied reverse bias. Potential barrier across DR increases. Semiconductors devices utilizing eccentric semiconductors. Example of semiconductor devices that uses eccentric semiconductor includes diodes, transistors, and solar cells. These devices rely on the controlled movement of charge carriers within the material. The properties of eccentric semiconductors plays a crucial role and important role in the performance of these devices, and this is the picture of the example of semiconductors. Temperature depends on eccentric semiconductors. The conductivity of eccentric semiconductor is strongly influenced by temperature. As temperature increases, the number of thermal, thermally generated charge carriers also increases. Careful consideration of temperature effects is essential for the reliable operation of semiconductor devices. And this is the photo of eccentric semiconductors in the temperature depends. This is the N type and this is the P type. Application of eccentric semiconductor. Eccentric semiconductors are integral to modern electronics, powering devices ranging from smartphones to computers, and it means eccentric semiconductor conductors also used in smart technologies. There are also used in renewable energy technologies like panels. Continued research and development in eccentric semiconductors are driving advancement in various industries also. Future trend in eccentric semiconductors. Future developments in eccentric semiconductors may focus on enhancing efficiency and performances. New material and doping techniques could lead to breakthrough in semiconductor technology. The versatility of eccentric semiconductors ensure their continued relevance in the ever-evolving field of semiconductors. Thank you, and thank you for watching my presentation, and thank you for giving this topic as a presentation of mine, and thank you.